So we're going to talk about usage considerations for Java ConditionObject. So as we saw when we went through ConditionObject, it had very flexible synchronization mechanisms. It allowed threads to coordinate their interactions to suspend and resume execution based on shared state, allowing threads to take turns sharing a critical section. So you could have them suspending and resuming. This is kind of like the way that the array blocking queue worked, where you could have a not empty condition and a not full condition and so on, and they could take turns releasing and waiting for things to happen. User objects can have multiple condition objects, which is nice, unlike the very crufty and limited built-in monitor objects, which have limitations. Condition objects can be defined in much more flexible ways. You can basically have separate wait sets or queues of waiting threads for different conditions, which simplifies the use of signaling. You can use signal versus signal all, for example. You have to be careful, however, when you use a condition object. You should almost always wait for it in a loop. There are some exceptions to this, but it's almost always the case that you want to have a loop as opposed to an if statement. And the reason for this is that due to the non-determinism of concurrency, by the time you return from a wait and reacquire the lock, the resource you're trying to get, the resource you were signaled about, may no longer be available, so you have to go back and wait again. And there's also something called spurious wakeups, which are a bizarre anomaly that can happen on some implementations of condition objects on multi-core platforms or multi-processor platforms. Read the link here. It's very, very strange and very mysterious why those would ever occur, but to guard against them, using loops will solve that problem as well. And you should be using a loop anyway for the most part. Bottom line here is you can have a thread awake from its waiting state even though the thread was not signaled on the condition object, which is bizarre, but read the link here for more about that. You always use condition objects in conjunction with a lock, most typically in Java with a reentrant lock. And we need to do this to avoid something called the lost wake-up problem. And this article here explains what the lost wake-up problem is. The bottom line is that if you don't have the lock held while you call signal or signal all, you can end up losing the wake-ups, which is a bad thing. Internally, when a wait is called, in a loop of course, you're going to internally, or it will internally release the thread, it'll release the lock and go to sleep. So internally it'll acquire and release the lock atomically with respect to sleeping and waking or suspending and resuming. So all that stuff is handled for you internally. You just have to remember that that's what it's doing. You have to be careful when you write your code to give a preference to using signal versus signal all, but what are the conditions under which you can do that? So using signal is generally a better thing to do to avoid the thundering herd problem we talked about. If you call signal all, that'll wake everybody up, even though only one thing can make forward progress, so you have the thundering herd. Here's conditions under which you can use signal. And this would be exemplified with our discussion about the array blocking queue and the example application we talked about before. So you can see here that they have what they call uniform waiters. If all the threads who are waiting on a given condition are waiting for the same condition, then you can use signal to wake them up because they're all waiting for the same thing. In this case, they're all waiting to see if the count is 0 in the case of not empty. Another one is one in and one out. So signaling allows at most one thing to go forward. And once again, we can do that here because when we put something in the queue, we want to let one thread make forward progress. So if both of those conditions hold, then you can use signal versus signal all. And the Java array blocking queue is an example of something that fits that, those criteria. Be very careful not to forget that condition await and condition signal all are not the same as wait, notify, and notify all. Even though it's tempting and easy to make that mistake, do not mix and match these things. Chaos and insanity will lurk there if you're not careful. And you can typically use condition objects in a way that reflects their usage. So not empty, not full, those are ways of awaiting for those conditions to be no longer true. So you're going to wait for the queue to be not empty. You're going to wait for the queue to be not full. Condition object is used in a number of places in the Java concurrency packages, Java util concurrent and Java concurrent locks. However, it's typically hidden by higher level abstractions like blocking queues rather than exposing it to application programs directly. So you almost always see it used through some kind of higher level abstraction like a blocking queue of some form. Okay, so that is the end of that discussion.